Nick, you're Professor of Engineering Physics. Can you tell me a little bit about your research? I mean, you've clearly got some kind of an experiment set up here.
Yes, I'm interested in ionized gases. We call them plasmas, and I'm interested in what they can do to materials like this. This is a semiconductor wafer. It's a single crystal of silicon. Wow. And it's used for manufacturing microchips. And patterns are made on this, and then it's cut up and put into mobile phones, cameras and memory chips and so on. Now, in order to do that, it's done on such a fine scale that you can't do it with drills and knives. It has to be done on a much, much smaller scale than anything physical like that. And so it's done with a combination of photographic techniques and plasmas to do etching, to put different atoms in specific patterns onto the surface. And I'm interested in the plasma that does that. Now, the plasma is an ionized gas. And I've got an example of an ionized gas here. This one's at atmospheric pressure. It's existing between these two electrodes, between two little sharp points on the electrodes. Right. And we have a high voltage between them. That's what this coil arrangement produces, a very high voltage.
Yeah, is the pale sort of lilac coloured gas, is that the plasma?
That's the plasma that's glowing. It's like a very short lightning strike. Lightning strikes are much, much longer than that and quite a bit noisier. This one is quite benign and quiet at the moment, but we can make it make a noise. And it's going through the air, so if we move the air, it gets moved as well. Look, watch this.
Oh, wow.
And as it does that, you can hear the crackling. And that crackling could be actually modulated directly. We could make that happen. And you can even make that play music, in fact.
So the plasma will actually play music?
It can. That's entertaining and a bit of fun, but it's not as important as the manufacture of semiconductor circuits, which is a billion-dollar industry.
So that's your research. How does that then feed into all the teaching that you're involved in?
Well, here we've got charged particles doing things, and I'm fascinated by charged particles, particularly in the gas phase, and that's what plasmas are about. But I've always said at the Open University, I'll teach you about anything that's got charged particles in it, and that's more or less everything. And I've done it in materials, I've done it in engineering, and I'm doing it in physics now.
Are you involved in any of the Open University's online learning?
Yeah, this kind of experiment, we have to control it. It's an electrical experiment. You can control where voltages are, what currents flow, you can move things up and down. Doing this sort of thing was the inspiration for the Open Science Lab. We did it on one of my plasmas first, and when we saw that we could do that quite easily, I controlled a plasma in my lab, in this lab here, from Germany while giving a lecture, I suddenly realised we could do that with undergraduate students as well. We could take the laboratories to them, we could shorten that distance, and we can allow collaborative work. We can give people the opportunity to control oscilloscopes, to look at experimental data, real experimental data, through real experimental interfaces, just as if they were in the lab. And they can communicate with each other just as well as they can when they're in the lab. I mean, maybe they don't do the social side afterwards, which is a pity, but you can do an awful lot of collaborative learning with this internet online environment.
It's fascinating, Nick. Thanks very much.